Welcome back everybody for lesson 4 of our fractions unit. Today we're going to be looking at equivalent fractions and simplifying. Okay, so some of the skills you're going to need to have success in this lesson is continue with that fraction vocabulary. Make sure you're going to know what all the words I'm saying mean. If you don't, go back and look at the video for lesson 1 and lesson 3, which was about prime factorization, finding least common multiples and greatest common factors. I'm going to assume in this you know how to do that, so the parts we get to, I'm not going to show you how to do it. I'm just going to give you the greatest common factor and least common multiple. So if you're still having trouble with that, please go back and look at the lesson for finding least common multiple and greatest common factor. Why you should care about this? This is going to be necessary, this skill of finding equivalent fractions and simplifying, for every single kind of fraction problem you're going to get: adding, subtracting, multiplying, dividing. So it's going to be very important for you to be able to do all of this to get your final answers. Goals that I have for you guys for this lesson is to help you learn how to test if two fractions are equivalent or not, learn how to find missing numbers, numerators and denominators, and we're going to look at an actual problem using least common multiple for that, and how to make your own equivalent fractions using greatest common factor. Okay. So there's some new vocabulary I want to go over first. One is cross-multiplying. Okay, that's essentially multiplying the numerator of one fraction with the denominator of the other, and vice versa. So making a cross across the two fractions. And then a variable. Sometimes in math, when we don't know an answer, okay, we actually know an answer, but we don't know a part of a question. And to represent that space, instead of putting a question mark or leaving it blank, we use a letter. And most of the time, we'll use an X for that. And then proportional. Things are proportional when they change at the same rate, and you'll see what that means just a little bit later. And then finally, the identity law of multiplication. This is kind of the duh math teacher moment, okay? When we say that anything multiplied by 1 will stay the same. And it seems ridiculous that we have a whole law for that, but it's really helpful for algebra and for this. So let's make it happen. Equivalent fractions. Just as a reminder, I'm going to pull down the page a little bit. Equivalent fractions are fractions that are equal to each other, even with different numerical representations. Okay, so I've got some set up right here. I've got a 6 over a 9 and a 12 over an 18. And on this side, I've got 4 over 7 with 8 over 15. For some reason, it showed up on Microsoft Word, but when I made it the PDF, it's not up here. Okay, so if you're using one of my papers that I printed out, you'll have it. Otherwise, just bear with me at home. So when we're testing, we're going to use that thing called cross-multiplying, okay, where we're going to cross-multiply the numerator of one with the denominator of other. So I'm going to make a cross, right, like this. So in my first problem, I have 6 times 18. If you don't know what 6 times 18 is, don't be lazy, do the work. 18 times 6. All right, 8 times 6, 48. 6 times 1 is 6 plus 4 is 10, 108. Very good. Now let's do over here, 9 times 12. Again, if you don't know how to do it in your head, show the work. Don't be lazy. 8, carry my 1, 108. 108 equals 108. That's going to tell me that those two fractions are equivalent. If you can cross multiply two different fractions and have their products come out as equal, then you'll know that those fractions are also equal. Let's take a look at another one. Okay. 7 times 8 and 4 times 15. Well, I know that 7 times 8 is 56, so I'm just going to write it down. And I know that 4 times 15 is 60. Again, if you don't know, don't be lazy. Do the work for yourself. You guys can do multiplication. I know you can. But 56 does not equal 60. Okay? So that means that those two fractions are not equivalent. Moving down. You're going to have to bear with me because I'm going to have to fill in some of these missing fractions for you. Okay? But now we're going to start talking about finding a missing part of two equivalent fractions. Okay, we're going to be looking for a missing part. Let's fill in the numbers real quick. This is a problem I had on the piece of paper. It's 3/4 plus 1/5. Okay, now this isn't going to be a big, long video about adding fractions. We'll get to that a little bit later. But I want you to know that this skill is, in fact, used when you're doing your addition for fractions. Now, when you're adding fractions, you need to have a common denominator, and what we're going to use to do that is the least common multiple of our denominators. And in this case, the least common multiple of 4 and 5 is 20. Okay, so we're not even going to get into finding it. That's in lesson number 3. Go back and watch that if you need it. I'm assuming you can already do that. Okay, so what we're going to do is we know that 3/4, we know we're going to use 20 as our denominator, so we want to make 3/4 equal something over 20. Now there's a couple different ways we can do it. I'm going to show you one way. And then we're going to do the same thing with 1/5 is supposed to equal something x, that variable. That's the variable we talked about up above. That's going to be over 20 as well. Because we want them to have the same amount of parts so that they can fit together easy when we're adding. Okay? One way to do this is to figure out, how does 4 get to 20? Well, I know that 4 times 5 equals 20, so if I do the same thing times 5, 3 times 5 is going to give me 15. So I now have 15 over 20. That's going to be one way to find yourself an equivalent fraction, okay? We're using the least common multiple down here for 4 and 5. And we're figuring it out that way. Now, notice how I multiplied times 5 times 5. When I said proportional earlier, when we went over new vocabulary, when it changes at the same rate, that's this. I changed the top number by the same amount, right? By the same, not amount, by the same rate, times 5 to get there. That's what proportional means. And then it's also right there, the identity law of multiplication. I multiplied 3/4 by 5 over 5. If we look at that real quick, 5 over 5, well, 5 divided by 5 equals 1. Okay, so that's just saying that anything times 1, in this case 5 over 5, or 2 over 2, or 3 over 3, or whatever fraction you want to make with the same numerator and denominator, anything times 1 will stay the same. So we now have equivalent fractions there. Next off, what we can do is look at this one. I'm going to show you another way. Okay, that's a little more advanced. It's going to be what you use when you get into solving proportions, and it's very algebra intensive, so you'll be able to impress some of your older brothers and sisters if you already know how to do this. Okay, we're going to do that same cross multiply. Okay, my 1 times 20 I know is going to give me 20. And because these are equivalent fractions, remember I said these have to equal each other. So then I have 5 times x. Now, think of it this way. I've got 20 apples over here, and I've got 5 baskets. If I put the same amount in each, how many am I going to have? I just asked you a word problem for division. So if you think about it that way, you can know that what you need to do is divide it by 5. You need to take this 5 and divide it by 5. It'll cancel out. You take this 20, divide it by 5, and you'll find that 20 divided by 5 is 4. Okay? That means that my x, this missing x, when I get it all alone, is going to be x equals 4. Okay? That's the way. I'm going to go through it one more time real quick. I know it'll make the video a little bit longer, and I know that you can rewind it, but I want to say less words and just show you the math this time. Okay? Alright, so those are 2 different ways you can find out the missing numerator or denominator for your fractions, and it's something that you'll actually be doing when you are adding or subtracting your fractions. Last off, we're going to get to the make your own section of the video. Okay, we're going to make our own. Got a little bit of erasing to do for you. Okay, I'm going to skip this one in the interest of time because we kind of talked about it up above anyway, so don't worry about that. Simplify, reducing the numerical representation of a fraction by dividing both numerator and denominator by a common factor. Womp womp. Okay, so what this means is what we've been doing is finding bigger equivalent fractions. Now we're going to take smaller equivalent fractions. So when you get an answer to an addition or a subtraction or multiplication or division problem with fractions, you're going to end up with something like 26 out of 39, let's say. Okay. Now what you're going to do to simplify is divide by a common factor. I always suggest that we use our greatest common factor because that way we can do it in one step. Again, finding greatest common factor is going to be in lesson 3's video, so please go back and watch that if you can't do that. I'm going to tell you right off the bat that the greatest common factor for these two numbers is 13. So all we're going to need to do is do 26 over 39. We're going to divide the top and bottom by 13 over 13. Because remember, any number on top of itself is 1. Okay? Anything multiplied or even divided by 1 is going to stay the same. So we're just getting a different numerical representation for an equivalent fraction, and we want it to be the smallest, lowest terms. 26 divided by 13, we're going to go straight across with these, is going to give me 2, because 2 fits into 26 13 fits into 26 2 times, and then finally straight across again, 39 divided by 13 is 3. If you have any questions or it went too fast, please just rewind the video, take notes. Okay, feel free to come into class with questions tomorrow. Good luck.